Dear friends, welcome to my channel. Today we are going to see how to use POM-QM software to solve the linear programming problems using Simplex method. Now let us see the example problems. So operation research subject Simplex method. Hi, I am Anand Jaykumar A. So let us see the first problem. A company manufactures two products X and Y which require the following resources. The resources are the capacities of machine M1, M2 and M3. The available capacities are 50, 25 and 15 hours respectively in the planning period. Product X requires 1 hour of machine 2 and 1 hour of machine 3. Product Y requires 2 hours of machine 1 and 2 hours of machine 2 and 1 hour of machine 3. The profit contribution of the product X and Y are 5 and 4 rupees respectively. So this is a linear programming problem because the values change linearly. So let us see the formulation of the problem. So this is a maximization type of problem. Let us start the POM-QM software. So let us click on linear programming over here and we'll put Simplex method example 1. Let us go back to the problem. So there are just two variables and three constraints. The fourth constraint generally we don't need to define. So we are considering this as only three constraints. So three constraints and two variables. This is a maximization problem. Row names is constraint 1, constraint 2 and constraint 3. Column names x1, x2, x3 and give OK. So it is set now. So 5x1, 4x2. 5x1, 4x2. 2x2 less than or equal to 50. 2x2 less than or equal to 50. 1x1 plus 2x2 less than or equal to 25. 1x1 plus 2x2 less than or equal to 25. Next is x1 plus x2 less than or equal to 15. x1 plus x2 less than or equal to 15. Now we have entered all the constraints and the variables and the objective function. So let's click on solve. So we want the solution. So we are going to click on linear programming results. So we are getting the solution as 15x1 plus 0x2, it gives 75. So this is a maximization type of problem. So here also we can go to solutions and solutions list. We can also see the iterations involved over here. There are only two iterations in the simplex method. This we can see it. Okay. Now let us go to the second problem. ABC Printing Company is facing a tight financial squeeze and is attempting to cut costs wherever possible. At present, it has only one printing contract, and luckily the book is selling well in both the hardcover and paperback editions. It has just received a request to print more copies of this book in either hardcover or paperback form. The printing cost for the hardcover books is rupees 600 per 100 books, while that for a paperback is rupees 500 per 100. Although the company is attempting to economize, it does not wish to lay off any employee. Therefore, it feels obliged to run its two printing presses, 1 and 2, at least 80 and 60 hours per week respectively. Press 1 can produce 100 hardcover books in 2 hours or 100 paperback books in 1 hour. Press 2 can produce 100 hardcover books in 1 hour or 100 paperback books in 2 hours. Determine how many books of each type should be printed in order to minimize costs. So let us see the formulation. This is a minimization type of problem. Let us go to POM-QM, click on New. We write as Simplex method. Example 2. Let's go back to the problem. So there are two constraints over here, and it's a minimization type of problem. 600x1 plus 500x2. There are two variables here, two constraints here. It's a minimization type of problem. So row names are constraint 1, constraint 2, constraint 3. Column names are x1, x2, x3. Okay. So 600x1 plus 500x2. 600x1 plus 500x2. Constraint 1 is 2x1 plus x2 greater than or equal to 80. 2x1 plus 1x2 greater than or equal to 80. What is the second constraint? 1x1 plus 2x2 greater than or equal to 60. 1x1 plus 2x2 greater than or equal to 60. Now we are going to click on solve. So solution is 33.33 x1 and x2 is 13.33. Let us click on iterations. So there are three iterations over here to get the solution. Let us go back to the problem. So this is what they are getting. 33.33 and 13.33. So this is what we get it. And the solution is this is what we get. Now let us go to the third problem. An advertising agency wishes to reach two types of audiences: customers with an annual income greater than rupees 15,000, target audience A, and customers with annual income less than 15,000, target audience B. The total advertising budget is 2 lakhs. One program of TV advertising costs rupees 50,000. One program on radio advertising costs rupees 20,000. For contract reasons, at least 3 programs ought to be on TV and the number of radio programs must be limited to 5. Surveys indicate that a single TV program reaches 4,50,000 customers in target audience A and 50,000 in target audience B. One radio program reaches 20,000 in target audience A and 80,000 in target audience B. Determine the media mix to maximize the total reach. So this is a maximization type of problem. Let us see the formulation. So this is the formulation over here. We are having one objective function and three constraints. Now let us go to the POM-QM software. Click on New. Simplex Method. Example 3. So number of constraints is 3, number of variables 2, and this is a maximization type of problem. Row names is constraint 1, constraint 2, constraint 3. Column name is x1, x2, x3. Click on OK. So let us enter the values over here. So it is 5x1 plus x2. 5x1 plus 1x2. Then 5x1 plus 2x2 less than or equal to 20. 5x1 plus 2x2 less than or equal to 20. Then x1 is greater than or equal to 3. 1x1 is greater than or equal to 3. Next one is x2 is less than or equal to 5. Let us see it. x2 is less than or equal to 5. 1x2 is less than or equal to 5. Now let us solve it. We are getting the solution. 4x1 plus 0x2 gives 20. Let us see. So this is the value. Let us see the solution. Linear programming results. Solution. Iterations. So there are 4 iterations to get the solution for this when you do it using the simplex method. Dear friends, thank you for watching the channel. Have a great day.